Okay, so classical approaches. So first, let me start by introducing the idea of token. So a token is basically the basic unit of your text. As a human, we usually think that a sentence can be decomposed in words, and that's indeed one option. So you see here that if we have text, one thing that we can do is decompose these words, text into words. The other approach that we are probably familiar as humans is to use characters. So we can decompose our text into characters. Maybe less known, there is this option to decompose the text into subwords. And we will see that subwords are basically somewhere between words and characters, and we can build subwords by using some algorithms. The interesting thing is that we can choose one of these representations for our problem. And we have advantages and disadvantages depending on various points of view. In particular here, I will focus on the point of view of the vocabulary size, the sentence length, and the out-of-vocabulary tokens. I will start with the vocabulary size. So the vocabulary size is how many tokens we have in our task. And we can easily see that if we use words as tokens, we end up with a vocabulary size that is very big. Like here I put 80,000, but actually it can be much more. It can be up to 150,000, 200,000. If we use the opposite solution is to use characters. In this case, you have a vocabulary size that is very small. Like you just need letters, digits, and maybe some special symbols. So you end up with probably something that is smaller than 100 tokens. So these are kind of the two extremes. Subwords, as we said, is in between, because we have these tokens that are not as big as a word, but usually bigger than characters. And a small vocabulary size is usually better, and both from a computational point of view and for the result that we can have. So at this point, we would think that the winner here is the characters, and we should go with that. But before doing that, we have to look at the other point of views, and the second point of view is the sentence length. So at this point, we have seen in the previous two presentations that usually if we have a very long sequence, it may be a problem. So it is important to find a representation that keeps our sequence not too long. And here you see one example of what happens if we choose words, subwords, and characters. So if we start with words, you see that now I need only 2 words if I want to model, to represent the sentence "Hi there." If I go with characters, now I need 8 characters. So you see how characters lead to a much longer sequence. And again, subwords is somewhere in between. That will depend on the algorithm that I use to create these subwords. And as I mentioned before, a short representation is usually better, and this is true both computationally wise and result wise. So at this point, we have this conflict, because here, words are a better solution. The last aspect that I would like to show is this idea of out-of-vocabulary token. So basically, an out-of-vocabulary token is a token that has never been seen in training. So it means that the model doesn't know what to do with that token. And this is something that will definitely happen if you use words, because it's unrealistic to assume that your training data contains all the words in the world. So you will end up with out-of-vocabulary, and this will be a challenge for your model. On the other hand, if we go with subwords and characters, is the opposite. So most probably, in particular with characters, the model will see all the tokens during training, and because of this, we will not have this problem of out-of-vocabulary. So again, here it seems that if we go with characters or maybe subwords, we can do better. Putting everything together, so we saw that every choice has its own advantages and disadvantages. It obviously depends on which task you are trying to solve. You may want to experiment there, but I would like to remember that subwords that maybe are less known are actually a very good choice because it's this interesting trade-off between word and characters where you avoid the too extreme cases, so the too big vocabulary or the sentence that is too long. So subword is actually a good choice that also helps with the out-of-vocabulary problem. In any case, in this presentation, for the sake of simplicity, we will consider token equal to word, just because as humans, it's easier to think in this term. Okay, so now that we know that we want to use word as token, let's see how to represent these words. And in the past, we were using this one-hot representation that actually you already saw previously in this school. So the idea is that we will associate a token with a vector, and this vector has all position equal to 0 except 1. One position is equal to 1, and the index of this position is telling me which word we are talking about. And this actually comes with some constraints that are disadvantages. The first one is that, like if you look at the example here, if I have a vocabulary of 3 words, cat, dog, and house, if you see the representation here, so first you can notice how we represent that with the one-hot representation. So they are all zeros except one position, and this position is telling me which word we are talking about. But you see that if I have 3 words, I need a vector of 3 elements. And actually this can be a problem. We will see it later. Let's see another example. Now I have 4 words. So now I have cat, dog, house, and PC. And you see that now in order to represent this, I need a vector of size 4. So you get the idea that we have a constraint between the vector size and the number of words, so the vocabulary size. And you have seen that the vocabulary size can become very big in some cases, so this can be really problematic to handle in these cases. And also there is another disadvantage. So here, I'm going back to the first example. So you see the cat, dog, house. And you see that I'm plotting these 3 vectors in the vector space. And you see that all these vectors, they are at the same distance. In particular, maybe we would have liked that cat and dog, they to be closer than for example, cat and house, because that would give us some intuition on the semantics of this word. But you see that here, this is not happening at all, and in fact, this kind of representation is not giving us any hint on the semantics, which is something that which is a disadvantage. But let's say we go with that representation, so now we know how to represent words. The next step is how to represent sentences. And actually, we can use this bag of word representation that, if you remember, I mentioned at the beginning of the first presentation. And basically, we just take the one-hot representation and we sum them. So it's very easy to do and convenient. You see it here. You see the cat, dog, house. And basically, if I have the sentence cat, dog, house, the representation will be just the sum of these 3 vectors. So this one here. And you may see one thing. Here I have cat, dog, house. But if I want to represent house, dog, cat, for example, I end up with the same representation. So this is the problem that I mentioned at the beginning of the first presentation today. If we use this representation, we'll lose the order of the elements, which is very important information when dealing with text. And in fact, here you can see one example. You can see that the semantics can change dramatically if I don't know anymore what is the order of the words, of the elements.